All right, so we are live right now. So welcome back. So welcome all of you to this amazing platform of Tutee Learning. So today we're going to discuss about vector algebra, and this is going to be lecture number 5 of vector algebra, right? So if you have been following this particular platform from a long time, you must know that we have been discussing about the different theorems regarding the vector basics of vector algebra, right? So as of the last class, we finished our discussion on collinear and non-collinear vectors, right? So I hope the last class discussion was clear to all of you, right? Is this part clear to all of you? So the last class discussion was clear to all. So yeah, so I hope this particular discussion in the last class is clear to all of you, right? And with that part, we tried to understand that how am I going to relate the relation between two collinear vectors, right? So we saw that between two collinear vectors, I can represent establish a relation such that A vector is some scalar multiple times B vector. So this will denote that this particular vectors, that is A vector and B vector, are nothing but they are the coplanar vectors. I hope this is clear to all of you, right? So and with that we discussed about also that how can we get this condition that whenever we have 3 points, what is the condition for collinearity of 3 points, right? So we saw that it was the area of the triangle generated by the 3 points should be 0 in order to be it's a collinear points, right? So this is where we finished up discussing in our last class. So today in our today's discussion we're going to discuss about, so in today's class we're going to discuss about especially on the coplanarity concept of vectors and a bit on linear combinations. Linear dependence and independence study, right? So let's try to first of all understand that what is a coplanar vector. So if you recall that in our basics lecture, we have already discussed about the coplanarity concept, right? So coplanar vectors, coplanar vectors are such vectors which lie on the same plane. So if I have three vectors, so let us say if I have three vectors, because two vectors will always be coplanar, right? But if I have three vectors, then if they are lying on the same plane, let us say this is A vector, this is B vector, and this is C vector. If they are lying on the same plane, so this is my plane. Now you can imagine the plane as a 3D object or a 3D surface, right? Or a page. Okay, a simple plane can be imagined as a page or a flat page, right? Alright, so if they happen to lie on the same plane, then they are known as coplanar vectors, right? Now, the important part over here is to understand that how can we talk about this particular coplanarity concept, right? So let us say that I have two vectors which are coplanar. So let us say that I have two vectors which are coplanar, and if I want to talk or write a linear combination result of that two vectors in terms for the coplanarity relationship, then let me draw another third vector. Let us call that as r vector. Okay, so let me draw another r vector or the third vector, and then if I have these three vectors as coplanar vector, then I will see that I am able to represent a linear combination linear combination result as that r vector can be given as some constant or scalar times a vector plus y times another b vector. Okay, so if this particular relation holds true, then this is basically giving that our r vector is coplanar or coplanar with A vector and B vector. So if this relation holds true, then only I can say that my R vector is coplanar with A vector and B vector. I hope this is clear to all of you. Right. Now the test for coplanarity is simply like if you are able to replace or write this particular uh, third vector in terms of or a linear combination of the first two vectors, then that denotes that this particular vector is a coplanar vector. Right. Now another thing, if we try to relate it with the points, similarly, if we have 4 points, then the coplanarity concepts can be talked about. Let us say I have 4 points. Okay, so let us say I have 4 points and the position vector of each of the point is given as follows. So that these are the 4 points and the position vector of these 4 points are given as follows. Right. So if I need to talk about the coplanarity condition of these 4 points, the easiest condition or in terms of geometric figure, I can imagine this as the volume of the tetrahedron as volume of tetrahedron A, B, C, D to be 0. So if the volume of this tetrahedron A, B, C, D is 0, then I can say that this particular 4 points are coplanar points, right? So if I have this particular coplanar point, however, in terms of algebra, I can also write this particular same thing as, or maybe this volume of the tetrahedron can be written as. So if I have a vector, b vector, c vector, and d vector, the position vector, such that individually the vectors can be written as a1 I cap, a2 j cap plus a3 k cap. Similarly, my b vector can be written as b1 I cap plus b2 j cap plus b3 k cap. Similarly, my c vector can be written as c1 I cap plus c2 j cap plus c3 k cap. And similarly, my d vector can be written as d1 I cap plus d2 j cap and d3 k cap. So if I have the following position vector with the component as follows, then I can write the volume of the tetrahedron. Then I can write the volume of the tetrahedron as a1, a2, a3, 1, b1, b2, b3, 1, c1, c2, c3, 1, and then I can write d1, d2, d3, 1, and this particular determinant will denote the volume of the tetrahedron whose coordinates of the 3 points or maybe the position vectors or the component of the position vector are given as follows. This component of position vector is nothing but they are the coordinates or the 3D coordinate, right? So this is my volume of the tetrahedron, right? So volume of the tetrahedron is equal to 0, then this basically implies that this is a coplanar points. This is a coplanar point. I hope this particular thing is clear to all of you. Is this part clear? Is this discussion clear? Omnius, good job. Who is from that side? Biswajit. Yes. Okay. Is this part clear? Is this part clear? Please review this part and then tell me that is this part clear or not, because then I will ask you to solve this part as well, right? So in the question, we will try to see that how we can generate the results, right? However, an easier way to obtain the coplanarity condition is, I'm from IIT Kharagpur, okay? Yeah. So I hope you got your answer, Biswajit. Alright, so I hope this particular result is clear. Now, the easiest way to answer this is, also if I have these three vectors which are coplanar. So if I have these three vectors which are coplanar, now we can assume these three vectors, I'm in fourth year. Yeah. So we can assume this particular three vectors as a coterminus vector or such that they represent the co-initial edges of the parallelepiped or parallelepiped, right? So we can assume this as a 3D figure whose all the sides are parallelogram, right? Whose all the sides are like a parallelogram, right? So that is called as parallelepiped. and in that case also I can assume this. So something like this, let us say this is my origin, so this is my a vector, this is another vector b vector, and this is my c vector. So I can assume the co-initial vectors as a vector, b vector, and c vector, right? And then if I need to find out the volume of this parallel pipe or volume of this parallelepiped, this can be given as a scalar trivial product of a vector, b vector, and c vector. So where scalar trivial product is a vector trivial product which is defined as a vector cross b vector dot with c vector, or it may be also defined as a vector dot b vector cross c vector. Okay, so if I able to find this particular relation, then I'm going to get the volume of the parallel pipe, right? Now, however, if I for coplanarity, the volume of the parallel pipe goes to 0. So this particular volume goes to 0, and therefore another condition to write the coplanarity will be the volume of the parallelepiped should be equal to 0. So this way I will discuss about this in our upcoming lectures when we discuss about the scalar trivial product. Could you tag notes for these vector lectures? What do you mean by tagging the notes? Omnius, what do you mean by tagging the notes? I can share you the PPT or the PDF note of this particular things. For that, you have to join our Telegram channel. Okay, we have already created our Telegram channel where we are basically constantly sharing up all the notes of JEE Mains and Advanced lectures. Okay, so please join the Telegram channel so that you get this lecture notes. Okay, all right. So this particular thing is called as a scalar triple product, right? Scalar triple product, right? So which we will discuss up in our previous future lectures. Okay, so in our future discussion we are definitely going to discuss about the scalar triple product. Okay, so we are going to discuss about this in detail. Okay, because these are really interesting topics. Okay, that is a triple product of vectors, or STP, scalar triple product. I hope this is clear to all of you. So this is another easy way to represent the coplanarity conditions. Okay, even if you have 4 points, you can try to form 3 vectors from these 4 points, something like this. This is one vector, this is another vector, and this is another vector, right? So in this case also, if you form 3 vectors, in this case, this is my d vector minus a vector, this is my c vector minus a vector, this is my b vector minus a vector, and then I can find out the scalar trivial product of these 3 vectors, right? And if this is equal to 0, then this is also a coplanarity condition. Okay, this is also the coplanarity condition. I hope you can understand the word. Okay, please follow the description box. Okay, in the description box you can find out the Telegram channel. Okay, so please join the Telegram channel so that you want to get access to the notes, and in case if you want to get mentorship or you want to get a doubt cleared, you can contact me on this particular number. Okay, so please contact us on this particular number so that whenever you have any question or you are basically interested in joining the one-on-one live batch, please contact us on this number. Okay, is this discussion clear to all of you? I hope this discussion is clear. Is this discussion clear? Omnius, please focus on the lecture. Okay, those apart things, those secondary things can be taken up. Okay, but please focus on the lecture right now. Okay, and after the classes is over, I will definitely share this lecture in the Telegram channel. Okay, but for the time being, please focus on the topics. Okay, so this is what you need to basically study as a part of the basics part of the vectors, right? So later with this particular understanding, let us try to solve some JEE Mains previous year question. Okay, some JEE Mains previous year question. So let's try to solve some JEE Mains previous year question, and with that we'll try to see that whatever we are learning, how that is going to help us in solving questions. Okay, generally if you try to solve the previous year question, mostly you will see that the questions are from the vector products, okay, or product of vectors. However, there are certain questions where you need to apply this particular basic part, right? Especially questions of vector algebra involving geometry. Alright, so I will try to show you some question of that particular part so that you can understand that how important is to understand the basic portions. Okay, like for example, let me take a very simple problem from the previous year JEE Mains. Okay, so it's a JEE Mains previous year question. So it's a JEE Main previous year question from 2024 paper. Okay, so if you look at this question, the question says that if you have a triangle, let us say this is my triangle ABC. Let us say this is my triangle ABC, where the position vector of this is given as A vector, B vector, and C vector, and these are given in the problem as A vector is given as 2i cap plus 2j cap plus k cap. Alright, and similarly B vector is given as I cap plus 2j cap plus 2k cap, and similarly C vector is given as 2i cap plus j cap plus 2k cap. So this is what is already given in the problem. Okay, and it is said that let L1, L2, L3 be the length of the perpendiculars drawn from the orthocenter. So for this particular triangle, if I draw the orthocenter, so from this, if I draw a perpendicular on the sides AB, BC and CAC, then this perpendicular length, is given as L1, L2 and L3 respectively. Okay, so these are the perpendicular length. Okay, so this perpendicular length are given as follows. Alright, so these are the perpendicular length L1, L2 and L3, right? So if I have this length as follows, and in the problem it is asked that if you have this relation, please try to find out the value of L1 square plus L2 square plus L3 square. So you have to find out the value for this particular relation. So please try to solve this problem, whatever you have studied, and by using your basics of triangles, please try to solve this problem. So it's a very simple problem of triangles. You can convert that into the triangle problem, right? It's a very interesting problem and very easy as well, right? Please try to solve this problem. Viswajit, sir, is skeletal product of BAC is equals to ABC. No, it's negative of that. Okay, skeletal product of BAC is negative of ABC. Okay, because if you do odd number of interchange, then the result is negative. If you do even number of interchange, then the result is the same. So if you do even number of interchanges, then it will be the same. Okay, whereas over here, if you look, you have done a odd number of interchange. Okay, you have interchange A and B, only A and B. So that basically counts as odd number of interchange. So which is not equal. However, it is equal to negative times that particular part. I hope your doubt is clear, Biswajit. Is your doubt clear, Biswajit? Please let me know. Okay, I hope your doubt is clear. So please try to solve this problem. Please try to solve this problem. Please solve this problem. Great. Please try to solve this problem. Any answers from anyone? It's a very straightforward, simple problem. Okay. Please solve this problem. All right. So let us see how we can proceed to solve this problem. Now, if you recall that in our basic discussion, we have seen that position vectors or the components of the position vector are nothing but they denote the points or the coordinates of these points, right? So over here, so from this position vector, I can write the coordinates of the point as follows. For A, it is 2, 2, 1. For B, it is 1, 2, 2. And for C, it is 2, 1, 2. Right? So the coordinates of these points are obtained. Right? Now, once I obtain these coordinates of the point, my next task is to find out whether is it an equilateral triangle or not. Let's try to check. Now, why I am checking it? Because if it is an equilateral triangle, then my orthocenter and my circumcenter or the incenter will all lie on the same point, that is the centroid, right? So if I am lucky in this scenario, if I am able to see that whether this triangle is an equilateral triangle or not, then it will be the lying at the centroid. Then I do not need to find out the orthocenter specifically, right? So let us, if I look at this and if I try to find out the value for the side length AB, so what I observe is that it is going to be square root of 2 minus 1 whole square plus 2 minus 2 whole square plus 1 minus 2 whole square. Now this will come out as square root of 2. Now interestingly, if you also find out the value for BC, it is going to also come out as, so if you do that, it will also come out as root 2. And similarly, this is also equals to length of line segment AC. So what you observe is that your triangle ABC is an equilateral triangle. That's why I was saying that this question is a very simple problem. Okay, so if it is an equilateral triangle, then your orthocenter is going to be the same as their centroid. So orthocenter is same as the centroid, right? So for equilateral triangle, orthocenter is same as a centroid, and I can find the centroid by this particular formula which we have learned in our previous class, which is equals to a vector, b vector, c vector divided by 3, where a vector, b vector and c vector denotes the position vectors, right? So if I try to do that, I'm going to obtain the centroid which is equals to orthocenter as 5, 3, 5, 3 and 5, 3, right? So it is going to be obtained something like this, right? So once I get the centroid, the next task is to plot or drop a perpendicular, right? Now again, if you recall that the perpendicular bisector will be the same as that of the median, right? So since it's an equilateral triangle, the perpendicular bisector will be the same as the median. So over here, I'm going to get, so that point, so if I try to find out the midpoint of AB, that is going to be the perpendicular drop. Okay, so that is going to be the perpendicular intersection, right? That is going to be the perpendicular drop, right? So the point where the perpendicular will drop will be equal to the midpoint, right? So if I name those points, let us say I name it D, this is E, and this is F. So I just need to find out L1 will be OD, L2 will be OE, and L3 will be OF. So I just need to find out those particular distances. So from here, so if I find out the midpoint of AB, so midpoint of AB is going to be D, which can be written as, so if I can find that as simply as A vector plus B vector divided by 2. So if I do that, the coordinate will come out as 3 by 2, 2, 3 by 2, which you can verify by yourself, right? Now, instead of finding out all the L1, L2 and L3 separately, you know this is an equilateral triangle, so all this length is going to be the same. So therefore from here, if I just find out only L1, it is equals to square root of 1 upon 36 plus 1 upon 9 plus 1 upon 36 is simply taken by from these results. Okay, so the subtraction of these two coordinates, right, and square of that. So if you find this out, your L1 will be going to be equals to 1 upon 6, which is also equals to L2, which is also equals to L3. So L1, L2 and L3 is going to be the same. So you will have same L1, L2 and L3, right? So therefore from here, if you try to find out the value of L1 square plus L2 square plus L3 square, this is going to be 3 times of L1 square, which is equals to 1 upon 2. So the final answer to this problem is going to be equals to 1 upon 2. I hope you are all getting the same answer. I hope you have tried to solve this problem and you're getting as 1 by 2 as the answer. Don't forget to share the notes of this vector chapter. Yes, I will definitely share the notes of the vector chapter and I am already doing it. Okay. So please join the Telegram channel and you will see the notes. Okay. So please join the Telegram channel and so as to get to access to the notes. Also, we have launched our website. Okay. So you can check out our website. Okay. So you can check out our website to get access to these notes as well. Right. So please check out our website as well. There the notes are also present. Okay. So all those notes, all those video lectures are also being present over there as well. Okay. So I hope this is clear to all of you. Please let me know is this clear or not. Is this question clear to all of you? Is this question clear? All right. So there will be some easy problems like this type only in the examination. Okay. All right. Let us try to see some more examples relating to the vector addition and subtraction results. Okay. So let me take an example or some questions from the previous JEE Mains problem. So this is again a JEE Mains problem from the 2024 paper only. So, oh, sorry, 23 it is. Okay. So the question is, it is said that you have been given as ABCD be a quadrilateral. So let us say you have an ABCD which is given as quadrilateral. Okay, which is given as a quadrilateral and E and F are the midpoints. E and F are the midpoints of the diagonals of AC and BD. So for the quadrilateral, E and F are the midpoints of the diagonal AC and BD. So if you have these results, then you have to find out the value of the expression AB minus BC vector plus AD vector minus DC vector is equals to some constant times FE vector. So you have to find out the value of this particular constant. So find out the value of this constant K. So please try to find out the value of this constant K. This is your question. So please try to solve this problem. Very straightforward problem. So please try to solve this problem. Sir, which are the high weightage mathematics chapter? The most high weightage mathematics chapters, if you're looking for any engineering based examination, is definitely going to be the calculus. Okay. So integral calculus and differential calculus will be the most high weightage topics. Okay. And along with that, vectors and 3D geometry is also equally important. Okay. So you will see that vectors and 3D geometry will also have some equal weightage in your JEE Mains and Advanced paper. Okay. So even if you study this particular chapter very nicely, at least you can be sure that at least there will be some 3-4 questions coming up in the paper that we will be able to solve it. Okay. So the weightage of this particular chapter is also very high. All right. I hope I was able to answer your question, Biswajit. Omnius unable to solve. Please learn from the solution. Please give some time and try to learn from the solution. Okay, whatever I am teaching, please try to follow it carefully so that whenever you are answering and whenever I am asking you to answer, you will be able to answer it. Okay. So please try to invest some time. It is not a one-day activity that you will be able to solve just in one day. Give some time. Okay, it will definitely take some time to develop this aptitude towards solving these kinds of problems. Okay. So let's try to see this problem as well. All right. So if you see this problem, this is again a very simple problem. All right. So let's try to see the solution for this problem, right? So given in this problem that I have ABCD as some quadrilateral, right? So let's try to draw the quadrilateral as follows: A, B, C and D, and the diagonals are AC and BD as follows, right? So if I have this setup, now what is said that it is said that E and F are the midpoints of the diagonals. So let us say this is my midpoint of the diagonal AC and this is my midpoint of the diagonals BD. So E and F are the diagonals midpoints. So if I try to find out, so in order to solve this kind of problem, let us consider that A vector, B vector, C vector as the position vectors of the given coordinates. Right. So if I assume this as the position vectors, then it will be easy to solve this problem. So let's first assume the position vector as follows. Then if I try to ask you that what is the position vector of E, so you will say that the position vector of E is nothing but A vector plus C vector divided by 2. And similarly, if I ask you what is the position vector of F, it is basically B vector plus D vector by 2. Right. So from this, if you try to look at this expression, that is, you need to find out for, that is, AB vector minus BC vector plus AD vector minus DC vector. Now if you try to write this in terms of the position vector, you will observe that this is basically coming out as B vector minus A vector minus of C vector minus of B vector, and this part plus D vector minus A vector plus minus of C vector minus of D vector. Right. So if you try to simplify this relation, you will see that this will come out as 2 times of B vector minus A vector minus C vector and plus of D vector, right? So if I can simplify this expression, I can write this as 2 times of, now I can simplify in terms that I can combine A vector, B vector and D vector, and the minus if I take common, then it can be written as minus of A vector plus C vector, right? So I can write this like this. Now this can also be written further. If I divide by 2, then I have to multiply by 2, and I can write this expression as 4 times of B plus D vector by 2 minus A plus C by 2, right? So this will definitely give me, so this is nothing but my F position vector, right? Minus, and this is nothing but my E position vector. So, and that is equals to 4 times of that, right? So if you see the expression over here, this is basically, so F minus E, or E minus F. So E minus F, so this can be written also as minus 4 times E minus F, that is final minus initial, which can be given as F E vector, which can be given as minus 4 times F E vector. So therefore the value of K over here, now I have seen many students do this mistake because of the hurriness. Okay, so generally they don't see that this expression and they directly answer the question as K equal to 4. But please note that the question asks you the answer in terms of FE vector. So over here it is given as FE vector. So you have to let me know the answer in terms of FE vector, that is E vector minus F vector. That is going to be minus of 4. So from here the value of K will come out as minus of 4. I hope this is clear to all of you. Is this part clear to all of you? Is this part clear? Please let me know, is this part clear or not? Okay, so this is how you solve questions on basics of vector algebra, right? So once we are done with the basics of vector algebra, now our task is to discuss about the multiplication of vector. So in our upcoming lecture that is going to happen tomorrow, we're going to discuss about multiplication of vectors, and we're going to start with understanding dot product or scalar product, right? And with that we're going to see what are the different applications of vector dot product, right? So it is not a vector result, so it is a scalar result, so we call it a scalar product, right? So when we multiply two vectors, I can have a scalar result, I can also have a vector result. So I'm going to explain all those things in detail in our upcoming lectures. So with this part I would like to conclude the session over here, and if you need this particular platform, please subscribe to the channel and share these videos among your friends, your juniors, as well as your relatives. Okay, and also hit the bell icon so that whenever we are live on this particular platform, you definitely get a notification. So with this, and also please like the video and please subscribe to the channel. Alright, so with this, I would conclude the session over here, and thank you for your all lovely attentions.